space, c'è 70 schermi di 286 megapixel.
Il doppio dell'alta risoluzione che abbiamo nei nostri TV a casa.
Ogni 4 schermi hanno un computer.
E dove sono questi computer?
Sono dietro. E questi è Dell XPS gaming computer.
Cioè dedicati al mondo del gioco? Vengono dai videogiochi?
No, per questo uso no, ma
certo.
Questi computer.
Quindi ogni computer 4 schermi.
Ogni computer 4 schermi. Ci sono 16 computer, credo. E c'è un altro computer che si chiama
Quindi un computer centrale dà gli ordini a tutti questi computer per visualizzare le immagini sui 70 schermi a doppia alta risoluzione.
What I have here is an Android tablet, and on it we're running an augmented reality application, and basically you get a camera view of what you're looking at. But if we hold it up here, what happens is it recognizes our digital version of the Vasari fresco, and then what we have here is overlaid. This is a blend between visible and thermal imagery. So let me switch to just thermal. And so what this shows is these discontinuities here in the thermal signature. So basically these dark areas are cooler areas in the Vasari wall. And so then we can do things like blend this into a visible. You can kind of see where these areas are in relation to the visible area of the painting. So if we bring back the other hybrid view, this kind of highlights those areas on the visible image. So you can really see this crack here, which is somewhat viewable when you're just looking at visible, but here it's very prominent. And then so we can blend and see how things match up. And then another thing you can do is, let's go like this. You can also go and say wipe with your finger to kind of explore the other data we have. And it just overlays that on top of what you're looking at.
Blend in and look at the thermal image underneath, right, which actually highlights some of the features that we see here. Now through the thermal signature, which says, oh, there's actually quite a bit more of a temperature variation in that areas of these cracks than we might expect from the surface. Right? So there's a fine crack here, but a very wide thermal signature, which means there's either a very big crack behind it, or the material has detached from the surface and cold air is flowing behind it. And it turns out it's both. So there's a much wider crack behind the surface as well as the material having detached.
Could you explain what thermal different means?
So the thermal imaging measures temperature variation, so something being colder or warmer than something else. So we get a grayscale image where temperatures, colors, dark colors, darker grade, map to lower temperature, and higher grade, lighter colors map to warmer temperatures. And with these you then can highlight which areas are very cold, which areas are very warm. So you see that the surface of the Vasari is warmer than the areas where we have the cracks, which means there's airflow for one behind the wall. And the question is, how does this airflow articulate itself And what does it mean? Right? Are these cracks? Are these changes within the fresco, within the wall behind it? Are there separations in the material?
It's a place to investigate.
It's a place to investigate, a place which was studied very carefully to come up with recommendations on how to preserve the Vasari more in detail. Right? There's indeed tremendous cracking all over. There's a delamination actually of the stucco itself. So what you're doing right now is actually intriguing, and you're doing that implicitly. So we have digital zoom, right? So through my gyroscopic mouse here, I have full access to the data, right? I can zoom in and zoom out. So I can take in the big picture, see everything that is there. Massively compressed, of course, in this case, compared to the original. But now I can go in and zoom into any particular feature.
You can visualize the famous cerca trova over
such as
there.
the famous cerca trova right here. Right? There it comes. Here we are, right? So we can actually go places that in reality might be difficult to go to.